Hi, welcome to this DSA showcase session. Now we are going to have a presentation from Leonard Mabele. He is from Strathmore University in Kenya, and he will present the partnership work that he has been leading about TV white spaces and a general framework for dynamic spectrum sharing. Leonard, we are so glad to have you here. Thank you for accepting our invite and for joining the DSA Summit. Um, Please go ahead. The floor is yours.
All right. Thank you very much, Martha, for the introduction. And I'm happy to be here and present some work on a collaboration with the regulator on DSA studies. So the title of my presentation is basically Academia Regulator Collaboration in the Era of Dynamic Spectrum Access. And we're just going to share the experiences we've had on TV white spaces here. So next slide, please. All right, so our work with Communications Authority began way back in 2017, just coming from background studies Strathmore had done on TV white spaces with partners in the UK and of course, University of Strathclyde in Scotland and African partners in other countries in Africa, academic institutions in Ghana, Malawi, and Namibia. So we've had all these activities going on for some time since 2017, and just last year in January, we managed to sign a memorandum of understanding between ourselves and Communications Authority of Kenya. And basically, the umbrella of our work is looking at how do we drive the dynamic spectrum access studies forward, and not only from an academic standpoint, but the adoption that DSA could get for the country, specifically from beginning of from TV white spaces, IMT bands, 5G, and other technical techniques of SDRs and cognitive radios. And lucky for us, coming out of the MOU in 2019 December, we were funded by the DFID to be able to push for the validation of the regulatory framework for TV white spaces in Kenya. And that project was officially began in January this year and ended up it ended a few months after August. It's 2 months after August, that is October 2020. And at this point in time, we are just getting to make assessments coming out of the field surveys that were done in various counties, some theoretical measurements and the technical tests to be able to have a concrete strategy of implementing TV white spaces for Kenya. Next slide, please. So our TV white spaces journey, I kind of alluded to it in the previous slide, but it's taken almost 8 years since the first trial was issued. The first trial for TV white spaces was issued for the country, and that was in 2013 August. That was the first trial of TV white spaces that happened, I think, pretty much on the continent, and it was done in the northern part of Nairobi, the capital of Kenya. And since then, we've been drawing lessons from those studies, and of course, at the time, TV white spaces were pretty premature. The regulator was a little held back in implementing TV white spaces. And besides, there were no conversations for database implementations until the May 2018, when we at Strathmore University, together with the research partners in the various countries, ran a trial of TV white spaces integrated to a geolocation database. And this sort of formed the basis of Communications Authority's strategy on going forward to roll out a regulatory framework for TV white spaces. So since 2018, which is like now 2 years, we've had a lot of tremendous developments for TV white spaces. And with our MOU coming up live last year, we have had the studies for technical, trials on the ground in various sites, as opposed to the initial site that the TV white spaces trials have been conducted, carried out from January 2020. And in March 2020, just the collaboration we had with Communication Authority enabled us to release a framework that was shared on the regulatory's website to have public input and participation from other stakeholders. And that sort of forms the TV white spaces journey for Kenya. And of course, even as I speak right now, we have not been able to, the framework has not been released officially yet, but we are happy to report that we are in the final stages of releasing the framework. Next slide, please. Now, so in this slide is some of the findings that we've had for TV white spaces. So as I've mentioned earlier on, the first pilot for TV white spaces in Kenya was done in 2013. And why we're calling it Mawingu is because the project was called Mawingu Project. Mawingu is a Swahili word, which means cloud in English. And we drew quite a number of lessons from the 3 sites that the infrastructure was set up, covering up to 14 kilometers. And just coming out of that, there even without the database, we were able to kind of find out that no interference was actually, kind of felt by the incumbent DTT services. And then I think the value that the infrastructure, the pilot infrastructure set up, provided a link of above 20 Mbps, and that kind of throughput output gave us a very nice baseline to set up kind of the baseline that would push for adoption of TV white spaces by other stakeholders apart from Mawingu. The Mawingu project basically gave birth to a startup company called Mawingu, which up to now is a tier 3 service provider, network facilities provider for Kenya. And again, moving forward from the trials in 2018, that is the integration with the geolocation databases, we still did not have interference. I mean, we used the Nominate database. Actually, I'm happy I was part of the team that set up the base station from Adaptram syncing with the Nominate database. And at the time, again, we never had any interference issues, and the coverage was great. Of course, the pilots were shut down after, since all the licenses were still in trial phase. But coming into the 2020 more findings and studies, that we were able to identify more spectral opportunity in other areas. Looking at the other image, the last image that has the spectral opportunity for SS 2020. So we saw quite a number of channels allocated out to the DTT services, but there was so much unused. So with these unutilized assignments, the 2020 studies have been able to pull out over, above 10, channels assigned that are just available for TV white spaces. Next slide, please. Yeah, so this is just an image picked up from the draft regulatory framework that Communications Authority released on its website in March this year. And it's basically borrowing a lot from the Dynamic Spectrum Alliance model rules of the second version, and also tying into the studies we've had on the ETSI harmonized frameworks. And then it's definitely, basically, it's looking at the similar approach that the UK has done. The only difference is that in Kenya, the implementation of TV white spaces will not be a license exempt like the UK or the US. We are having it's granted a likely license. So it's the likely license model that is being embraced for TV white spaces here. And the summary of this image is just looking at the regulatory interface in terms of integrating to the portal that is in sitting below the TV white spaces databases. And then all this is tying into the network operators just having their authorization of the white space devices. It also adds up into looking at how the infrastructure of coexistence between the DTT services and TV white spaces looks like. So from a standpoint of, from a regulatory standpoint at this point, I mean, as a draft, that's what I mean, we have the likely license model approach, and then we will be using the geolocation databases approach. In our regulatory framework, or in our draft regulatory framework, we have not mentioned anything on spectrum sensing model. So our adoption of implementing TV white spaces as a draft at this point is we'll leverage the geolocation databases approach. Next slide, please. Yeah, so again, just looking at the lessons that we've been able to extract or derive from the partnership we've had with our regulator, particularly looking at what will be the potential for TV white spaces. On the first point, we are pushing for TV white spaces as a rural wireless internet provision ecosystem, and we are looking at most of the rural areas in the country getting connected to the internet through TV white spaces, health centers as well, technical institutions. Now, the truth is, majority of the population in Kenya lives in the rural areas, and we see a very great potential of adopting TV white spaces as a value-adding service, just enabling the rural areas to be connected, and also access the e-government services. Because at this point in Kenya, no one can be able to get a passport or a driving license in a manual process. You have to do that on an online platform provided by the government. But now with a disconnected ecosystem, or with the problem of the digital divide, where the rural communities are not as connected to the internet as the urban counterparts, it basically means most of these services from the government will not be accessible to them. So as a potential opportunity, just pushing towards the services, it's rural wireless internet provision for rural areas is really key as a service for the adoption of TV white spaces. And then additionally, some of the studies we've also found out, and based on the research that we're conducting here at the Strathmore University, is the adoption of IoT services. So IoT has become a big topic over here. Industry 4.0 has been discussed in virtually every, at this point, virtually because of COVID challenges. But since 2017, we've had a lot of conferences, events, workshops organized on Industry 4.0, and we have quite a number of IoT solutions emanating from the market. And that for the rural communities or for the unreachable communities or areas where the infrastructure for mobile, for cellular bands or IoT services that have not reached well, TV white spaces to be the best platform to leverage or the best connectivity approach to adopt for that. Now, adding on to some of the studies that we are looking into this, even as TV white spaces gets its green light in the coming days from the regulator, we are still handling that or dealing with the challenges of the return on investment to the operators, return on investment to the investors that will come to deploy the TV white spaces. Well, of course, globally, everyone, just coming out of the studies we've had in countries in the UK, in UK, in Europe, other European countries, in Singapore, US, Canada, New Zealand, Australia, there's still the challenge of really embracing TV white spaces, and it's kind of pulling back the investors or even the mobile network, the operators, not the mobile network operators, but the network facilities providers in general to move forward and embrace TV white space, deploy it for the various services. And we here at Strathmore University are spending a lot of time just trying to study what will be the models of pushing for the business adoption of the business models that will drive the adoption of the technology. And again, not only looking at the business models, but also the technical approach and the technical skills. Because even as we speak about this, I think we've only had one consistent trial for TV white spaces in Kenya, and that has only been done in Mawingu. Mawingu is in Nanyuki, which is 300 kilometers from the capital, and we've not had any other deployments that have been left live. So that actually leads to the point of we probably do not have, well, we've not set up a very sufficient knowledge ecosystem to push for adoption of TV white spaces going forward. So a lot of our research activities together with the regulator are looking into that as well. And again, we of course embrace the geolocation databases model, but we are not sure at what point we need to adopt the geolocation databases. So most studies together with the regulators looking at what will be the challenges and limitations on TVWS adoption, are all looking at those aspects. So for next steps from us, coming out of a collaboration with CA, which, as I mentioned, our MOU was, signed last year in January, and it spans for 3 years. That means we have a lot of work to do until 2022. And at this point in time, we are starting to look at the best fit approach of implementing dynamic spectrum access in the IMT bands as well. So one of the conversations that we picked up with various stakeholders and partners is on the 2.3 gigahertz conversation on the 5G. Dynamic Spectrum Alliance has also been pushing a lot on the Wi-Fi 6. So these are the next step or the next pillars of study that we are beginning to look at together with the Communications Authority. So that kind of draws just in a bit brief, like the partnership we are having with the Communications Authority, and not only with Communications Authority, but also other stakeholders within the spectrum ecosystem. And that is the network facilities providers, academic researchers from the African continent, academic researchers from other continents, specifically a lot of work with the European countries, and also we're beginning work again, more research work together with the Dynamic Spectrum Alliance. So those are some of the things that we are looking at here, especially as we develop a more concrete collaboration or just sharing the lessons that we've learned between ourselves here as an academic institution and Communications Authority as a regulatory authority. And I just wanted to have that shared through this DSA Summit. And that brings me to the end of my presentation here. Thank you.
Thank you very much, Leonard, for this exciting presentation. I think it's great how you highlighted the collaboration between university and the regulator and international organizations. So I think it's really interesting, and I also look forward to hearing more from you in terms of future implementations of spectrum sharing, like for example, making very efficient use of the spectrum in some frequency bands that are already identified for IoT, or even what you mentioned about Wi-Fi 6. That sounds like very exciting. So thank you very much for this presentation, Leonard. And well, I invite all of you to continue watching this content and to continue connected to the DSA Summit. Thank you very much.
Thank you, Martha. Thank you very much.